In these problems, they ask us to decide if a sequence is convergent or divergent, and if it's convergent, find the limit. So we have negative 0.3 to the n, which can also be written like this. And so we evaluate a few terms. I put this into Wolfram alpha, and we see some alternating behavior between plus and minus, as we expect, because we have our -1 toggle. So the sequence is definitely not monotonic, but you can see that the 0.3 to the n here is going to, so remember we saw that if a sequence was bounded and monotonic, then that implied that it had to converge. So that's true, but a sequence can still converge if it is bounded and not monotonic, and that's what this example shows, because this sequence definitely headed to 0 because every term gets hit by another 0.3, driving it down to 0, but it alternates between plus and minus, so it's not monotonic. And here is the, you can see the graph. It alternates, so it goes negative to positive, positive to negative, negative to positive, goes like that. But it converges that way, so it sort of converges in a band like this down to 0. Another example we have here is this one. It looks kind of wild, and in fact I put this into Wolfram alpha, and the numbers are jumping around as the n increases, so you don't really know where they're going to go. Well, let's just look at it mathematically. Your nth term is going to be of the form 2n plus or minus 5 divided by 4n minus or plus 3. And that's because of this right here. Alright, so basically you can see that as n approaches infinity, the plus 5 or the minus 5 or the plus or minus 3 is going to be insignificant next to the size of the 2n and the 4n. That means that your sequence is going to approach 2n divided by 4n, which is 1/2. So you can evaluate a few numbers. N equals 100. You'll get 200 plus 5 divided by 400 minus 3, and that indeed starts to look like a half. When you pump it up to 1,000, 2,000 plus 5, 4,000 minus 3, you can see how the 5 and the 3 are insignificant, more insignificant, and now you're close to 0.5. So we think that the limit is going to be 0.5, and the sequence is going to converge. Then I took a look at this in the calculator. I put in y1, because remember you can do these in the regular y equals with the x's, or you can put in sequence mode and do it that way, but it's a little faster in the normal x and y form. So you put in the as a function, and then I set up a table. Table setup, I started with 1 because you want your n to be 1, and you want them to skip integers, so you want to have it be start at 1 and go by ones. And then if you do auto, then when you do second table, your table, you get these values, and these values exactly match up with these here out of Wolfram Alpha. But you're not going to get it very far. You still can't tell where it goes to there. So I set it to ask on the table setup this time. Ask for values. So then when I went to the table, I put in 1,000, and it gives you the y value, which is the sequence term value, 0.50163. And then I asked again, put in 100,000, and this time it gave me something very close to 0.5. So our mathematical analysis is matching up with our calculator table analysis, that the limit is 1/2 and that the sequence converges. Now we do one last example here. It says 2n, 2 over n, plus n over 2. So your first impression is that something's going to cancel out, but in actuality you can see that n over 2, that part's going to go to infinity as n gets very large, and your 2 to the n, or 2 over n, is just going to go down to 0 as n goes to infinity. So you're going to have something very large added to something very small, but that's going to be very large. So that's going to end up going to infinity, so the sequence diverges. So that's the way you're supposed to do these. A little mathematical analysis, some tables, a little graphing, Wolfram Alpha, calculator, a mixture of all those things.